Now let's move to the actual agent studio. So we have completed the guardrails studio, then we have completed the knowledge base. So one more thing to add up here is that you can only able to create one collection at a time right now. So if you saw the old IAM HR collection name got replaced with the new collection. So this is the one thing need to be uh, actually considered. So the collection can be currently supported only one, but you can upload multiple documents to the same collection and retry accordingly. It will retry according to the document from the collection. So now let's move to the agent studio. So we will move to the CFM lab later. Now, I have two agents over here, so I'll just delete one and we will create a new test agent. Then description for the agent is very important. It's kind of a system probe, you can say. So here you are a HR agent for safe health and support. So this basically gives the description for the agent which we are creating. Then we can select the domain. So either you can go with the uh, custom one too. But currently we are selected the HR policy engine. We have created a guardrail into our guardrail studio. So we are going to select that for using. So we have also the commitment level system that I will explain in a little bit of time. So right now for the knowledge base, we are going to select our the test knowledge base. Then CFM model, we don't need to select it right away. And we have the base fact system. So here you can just put your base facts if required, like employee count is 250. So you can add the base pack for your agent. Then we have the tool section. And in the tool section, so we have multiple tool option for the your agent to interact with. And we will select the notify for the demo. Let's create the agent now. So as you can see, the agent is created. Now, if I open this, so you can see you will get the API endpoint for your agent. So basically, if you have already have the website of your company and you wanted to um just integrate the agent and don't want to go into the coding part or any other SDK part, Buddhi SDK part, any other complexities, then you can just use the agent studio to create the agent and use this URL with your API key for the authorization and authentications. And then that's it. You will get it ready with your actual website. So whatever chat UI you wanted to add, you can add to your website and you can just call this URL with the goal as your message and the context if you wanted to provide to it. So that's it, right? Actually, for the agent, and we are now going to move forward to the playground part. So here now we are actually going to test our things. Let's have we will test first our test agent, which we have just created. So from here, I have selected the test agent. This is the Buddhi playground. So basically, here you can try your created things. Your agent test your agent before deploying for the public. So request 15 days leave for a month. So yeah, it is responded with the approve. Then let's have some salary discussions with it. I wanna know. about salary of my manager. Yeah, I can share the details about your manager salary. It's confidential. So basically, it's applying the rules which we have set it and providing like producing these outputs. So now, guys, I'm going to show you exactly how this system is like working. We are just checking the guardrails, for example. So if you see over here, uh, we have the custom my guardrail option. So whatever guardrail we have created from there, then we have commitment level system. So in the commitment level system, basically you can commit some fact like currently we are in the HR agent, but I can commit the fact like the patient is allergic to the penicillin, and as soon as you can see request is blocked because of the hard commitment has been detected by the Buddhi engine. So commitment are the things which cannot be broken. So these are always be blocked if you wanted to, or you can have the review with them. So both the options will be available. Then we have some other settings related to the complete system. Then you can also upload your custom YAMLs if you like. You can also develop it. We will provide the documentation to develop your custom YAMLs yourself. Then we have this energy landscape. So currently, you can say it's not, it's in the alpha mode right now. Then we have this active search simulation. So this is also in the alpha right now. So basically, guys, this is all is the actual Raksha platform. So Raksha platform is basically using the core models behind the scene to actually detect these things. So yeah, that I will explain like post it with the PPT on uh, the LinkedIn page of the company. Yeah. So this all together is current platform of the Buddhiengine. And now I'm going to show you some experimental things. So right now, this is not completely available to you. It's in the experimentation page. But in the casual forward model, basically you can simulate, explore, and build. So here I'm going to show you some examples like reactor control, financial transaction list, etc. And we have the casual change system also. Like you can initial pass the initial state and the actions for the simulation, and this model will be simulate those actions for you to identify what will happen if you perform some particular thing with some particular inputs. So for the this case study, we use this ISRO BARC DRDO systems just to test the simulation. It's a case study system. We did not have contacted with the ISRO BARC or any government of the India. We are just simulating the system, doing the case studies on the similar system like ISRO, BARC, and DRDO. So here we try to simulate it with the inputs like altitude kilometer, velocity, fuel, then orbital period. So these kind of inputs we are trying, then fire the thruster for 1 second, then adjust the altitude, then circularize the orbit. So these are some basically some actions which can be performed by the any satellite companies. So basically, this satellite research company. So basically, this can be do some simulation for you. So for example, I just click on the simulation. So the system uses the Buddhi Engine's deequilibrium system to identify the problems into the simulation. So it will identify the peak system. So initial stage is okay. Then large change detected in the alpha system shifted significantly. Basically, with these inputs, energy is automatically will get shifted. Then it is adjusted the altitude, then orbital altitude. So basically, you can do some predictions over here with these models, and these models can be also trained on the base knowledge of your system. So means instead of uh, randomly without a base knowledge predicting the things, we can provide the base knowledge of these scenarios to the model, and model will then perform the simulation according to the base knowledge, which will give the more reasoning capability to you. So these things are also available with this, and we are soon launching it for the actual use cases. So these are the some of the examples, like for the bark reactor or the mission critical things. So basically, for the bar kind of thing, so we can say we require the temperature, the balances, vitals, and initial state. Basically, it can be anything. So, but the reactor requires their temperature, reactor temperature, and other things like the coolant flow, then power output, then the pressure, the core temperature, Celsius. So these can be inputted to here, and you can just set your one line actions like increase the coolant, reduce the power, increase the control rod. So the insert the control rod. So this type of systems you can connect, and this model can then perform the simulation on the inputs and then identify the problems into the particular steps if those are performed by the actual real situation. So basically this is the casual forward models, and yeah, so this all together, guys, is Raksha M and the Buddhiengine platform. So we have now officially live with the Raksha M with this thing. Soon we are going to add the Vega Apex support too over here to manage your Vega Apex instances according to your needs and the Vega Apex models. And also you can download the Vega Apex, but you need the key to get it working into your games, Unreal Engine. So that is required on the first time only. You can use it offline also. And there are normal some settings and other things. So this is the complete platform you can say we have. And now let's move to the actual benchmark. So guys, I have prepared one benchmark script to show on the demo side. So basically, this benchmark script, I'm going to be posting it on the GitHub, on the Buddhiengine GitHub page. So there you can go and you can check this Python file and run it. Sorry, you cannot run it on your system. This is not using the Buddhiengine SaaS platform right now. It is running on the completely local system with the RTX 4070 GPU to test it, the memory and memory density and the compute and other thing. So let's run the benchmark of the geometric DB. So here, guys, we are using the real embeddings uh, of the embedding model, and we have uploaded the actual Tom Mitchell's machine learning book uh, for the benchmark. And if you see, uh, the PDF is around 17 to 18 MB. Then we have uploaded other files also. So total three files we have uploaded, and we got average memory gain of 22.5%, uh, 5x, 22.5x, and efficiency. Also, if you see the latency, then efficiency and the Buddhi RAM. So when the standard RAM is used for these documents, you can see the uh, consumption into the KB and with the Buddhi. So Buddhi basically uses the geometric container system to manage this data. So this is the completely uh, energy minimization inspired algorithm we have designed for the data compression and the retrieval system. So this is basically is getting used on the platforms also. So this is the core system which is now running on the RTX 4070 laptop. Uh, and its average latency is right now 30 millisecond, which is actually giving this latency is because we have training running behind the scene, and it's also taking too much of the uh, GPU, you can say the RAM and other things. So right now, I cannot provide you the exact latency, but yeah, I will provide different separate video for the same uh, execution soon on the website itself without, because right now we are only having the single GPU, so we are using it. So these are the benchmarks, right? Basically, of the geometric DB, you can see the geometric DB's efficiency and the Buddhi engine, how the Buddhi engine works and what the platform offers to you. So thank you guys. Thank you for the staying till this. If you watched till the end, thank you for it. And please try it, try it, try it. Yeah, contact us. Thank you.